Today we're going to look at solving linear systems using an algebraic method called substitution. So for our first example, we're going to solve 2x plus 3y minus 9 equals 0 with x minus y equals 2. If we look at the graph given here on the right, we see that these two lines intersect at the point 3, 1. So algebraically, we should be able to prove that these two lines do meet at the point 3, 1. Using substitution, there are a few steps we need to consider. So the steps for using substitution are listed here, and I'll go through those steps as I try to solve our first example. So starting with step 1, we're going to label both these equations. So I have 2x plus 3y minus 9 equals 0. I'm going to call that equation A. And x minus y equals 2. That's equation B. Step 2, I'm going to examine both equations for a variable that's easy to isolate. And when I look at the two equations, if you look closely at equation B, we see that the coefficient in front of x is 1, and the coefficient in front of y, which is negative 1, that those would be the easiest to isolate for. Where the coefficient is 1, that means you won't have to do any division. So let's isolate B for x. And what that means is I'm going to get x by itself on the left side and everything else on the right side. So I have x minus y equals 2. So if I want to get x by itself, I'm going to add y to both sides. So I'm going to get x equals 2 plus y, or y plus 2. I'm going to call that equation B star for now. So it's a modified version of equation B. And now step 3 says substitute this expression into the remaining equation. So I'm going to take this modified equation B and sub it into the other equation, which is A. And let's go through that. So I'm going to take wherever I see an x, which is right here, I'm going to replace it with 2 plus y. So I'm going to have 2 plus y, plus 3y minus 9 equals 0. Next step is to solve. So if I want to solve for this expression, first I'm going to need my distributive property to get rid of the brackets. So I get 2 times 2 is 4. 2 times y is 2y. Plus 3y minus 9 equals 0. Collect my like terms. I have a 2y and a 3y, so that gives me 5y. A 4 minus a 9 gives me negative 5. That still equals 0. Then I'm going to isolate for y. So to isolate for y, I'm going to add 5 to both sides. And then that leaves me with 5y equals 5. And then finally I'm going to divide. And then finally I'm going to divide both sides by the coefficient in front of the variable. So that is 5. So that leaves me with y equals 1. So now we know the y component for the point of intersection, which if we go back to the graph, we saw that the y component was 1. So we've got that correct. So now we need the x component. So if we go back to the steps, we've done the first 2, 3, 4 steps. So we're going to sub this value a into a or b and determine the unknown value. And you can use either equation. In fact, you can even use b star. So I'm going to use b star because that would be the quickest way to find the x variable. So b star was x equals 2 plus y. So I'm going to sub y equals 1 into b star. So we have x equals 2 plus y. That's our b star. We know that y is equal to 1, so x equals 2 plus 1. Therefore, x equals 3. And we've now shown that our point of intersection is x equals 3, y equals 1. The same thing we see up here in our graph. X equals 3, y equals 1. All right, last step. verify the solution satisfies A and B. So in this case, we do want to use equations A and B. We want to check that this is the correct answer, and this will check your algebra. If there's a mistake, then you need to go back to see where the mistake is. So let's go through that. So back to the bottom here. We're going to verify now by doing our t-charts. Our first equation is 2x plus 3y minus 9 equals 0. Our second equation is x minus y equals 2. Remember, our point is 3 and 1. So let's put in our x value. We get 2 times 3 plus 3 times 1 minus 9. Using order of operations, I get 6 plus 3 minus 9, which equals 0. Perfect. The next one, I'm going to do x minus y, 3 minus 1, which is 2, and we verified that this is correct. So whenever you solve a problem using substitution, always a good idea to check your work. All right, let's try this out 2 more times. So example 2, solve each system. So first step, we're going to label our equations. And I always like to call them A and B. Look for a variable that's easy to isolate for. And again, I always try to look for one that has a 1 attached to it. This one doesn't have a 1, but I see a negative 1 there. So I'm going to use that equation there, and let's see what happens. So I'm going to isolate A for the variable y. So to do that, first I need to get rid of that 6x. So I'm going to minus 6x from both sides. So I'm going to get negative y equals, I'm going to minus 6x from both sides, and then there's still that plus 1. The problem is I don't have y, so the next step is to divide everything by negative 1. So leaves me with y equals 6x minus 1. There's what we're going to call equation A star this time. We modified A. Now I'm going to take this A star, sub it into B. So wherever I see the y value here, I'm going to replace it with 6x minus 1. That is the substitution step. So let's write that out. I'm going to sub A star into B. So that gives me 3 times 6x minus 1 minus 2x equals 5. Next part, we're going to use our distributive property again to get rid of the brackets. And I get 18x minus 3 minus 2x equals 5. Let's collect some like terms. I get 16x minus 3 equals 5. And now we need to solve for x. So the first step, I'm going to add 3 to both sides. And if I add 3 to both sides, I get 16x equals 8. And finally, I get x is equal to 8 over 16 when I divide both sides by 16. If you don't see that there, I divided both of the sides by 16. Finally, we can reduce this fraction, so we get x is equal to 1/2. Now we need the y value. So I'm going to take this x value. Let's continue up here. I'm going to sub x equals 1/2 into, let's use A star again. So A star, recall, is y equals 6x minus 1. So therefore, y equals 6 times 1/2 minus 1. Half of 6 is 3. So therefore, y is equal to 2. So this time, we say that xy is equal to 1/2 2. That is the point where the two lines will intersect. And notice we didn't have to graph this time. Of course, last step is to verify our work. So we have to go back to our first 2 original equations. Always use the original equations. Our first one was 6x minus y equals 1. And our second one was 3y minus 2x equals 5. So let's sub in the values for x and y given by this point here. So I have 6 times a half minus 2. So let's check. Half of 6 is 3. 3 minus 2 is 1. That's good. So now again, 3 times y. So we'll get it mixed up. This time this is 2. Minus 2 times a half. 3 times 2 is 6. Half of 2 is 1. 6 minus 1 is 5. And we've shown that this is indeed the point of intersection for the original two equations. So for our last example, let's go through the steps one more time. We have equation A, equation B. Let's look for a variable that's easy to isolate for. And in this one, we have a choice of either A or B. I can isolate A for y, or I can isolate B for x. And no matter which way you do it, as long as you follow the steps, you're going to get the same result in the end. So let's say I take A for y. So I'm going to isolate A for the variable y. To do that, I'm going to need the minus 2x from both sides. So I get y equals minus 2x plus the 15 that was already there. This is going to be A star. And I'm going to take this and sub it into B, the other equation. So wherever I see a y value, which I see there, I'm going to replace it by negative 2x plus 15. I'm going to sub A star into B. And I'm going to get x plus 3 times negative 2x plus 15, because that is the new y value, equals 4. And then same as the last two we've done, we're going to use our distributive property. So I'm going to get x minus 6x plus 45 equals 4. So I'm going to group the x's, so that gives me negative 5x. I'm going to minus the 45 from both sides to get rid of that. And if I minus 45 from both sides, I end up with negative 41. Next, I'm going to divide by negative 5. So I end up with x equals 41 over 5, which cannot be reduced, so we're going to use that. So let's find the y value. So now I'm going to sub x equals 41 over 5. We've got the x value, so we need to find the y value. And we know the y value is given by A star, which is y equals negative 2x plus 15. So now we replace the x by this value that we have, negative 2, 41 over 5 plus 15. And remember, this is a fraction and we're multiplying. So we're going to multiply numerator by numerator, denominator by denominator. So I end up with negative 82 over 5 plus 15. So let's keep going. So we need a common denominator now to put these two together. So that's 82 over 5. That is 15 over 1. So the common denominator is going to be 5. So my equivalent fraction for 15 is 75 over 5. Multiply top and bottom by 5. And finally, we get a y value. If we take negative 82 plus 75, we get negative 7/5. So now that we have the y value, we put them together. So I've run out of space here, so I'm going to start way back up here. So let's take that up to here. We know therefore that xy is equal to, so we said x was 41 over 5, and the y was negative 7 over 5. So there is our point of intersection. If we were trying to graph this linear system, finding this point would be difficult. How do you see 41 over 5 and negative 7/5? So the algebraic method will help us find exact solutions. And again, the last step is to verify. I've sort of run out of space here, but let's try our best. We know the first equation was 2x plus y equals 15. 2x plus y is 15. So here we go with a lot of our fraction work here. So that's 2 times 41 over 5 plus negative 7 over 5. So remember that this is 2 over 1. So this is going to give us 82 over 5. Plus and minus means minus 7 over 5, which gives us 75 divided by 5, which equals 15. So this has worked. Now let's try the other equation. So the other equation is x plus 3y equals 4. So let's do that. So our x was 41 over 5 plus 3 times negative 7 over 5. That's 3 over 1. Multiply numerator by numerator, denominator by denominator. So I get 41 over 5 minus 21 over 5. If we subtract that, we get 20 over 5, which is 4. And again, we've shown that this point is indeed the point of intersection for the equations given above. So we go back up to here. Here are the two equations. Their point of intersection is right here. And that's showing all your work. So if you want to try some questions, here are the ones from the textbook I would recommend. And for those who want a challenge, of course, here is an extra practice question. I want to know what is the x, y, and z value to solve the systems. I should be able to show that a particular x, y, z will work for all three of these. That means when I go to verify, whatever x, y, z I get, I should get 12 equals 12, 9 equals 9, and 15 equals 15. Good luck.